Classification of matter. Matter can be classified in a number of ways. Earlier, Indian and Greek philosophers and scientists attempted to analyze and classify matter in the form of 5 elements: air, earth, fire, sky and water. However, physical states of matter. Commonly, a given kind of matter exists in different physical forms under different conditions. Water, for example, exists as ice, solid water. Solid, liquid and gaseous forms of matter can also be explained in terms of forces operating among constituent particles, atoms or molecules. These forces are called intermolecular forces. In the case of solids, these forces are strong enough to keep the change of states of matter. Effect of temperature. What will happen when heat is supplied to a crystal of a solid? Effect of pressure. In order to understand the effect of pressure on gases and liquids, element, compound and mixture. Before investigating the classification of matter by its chemical constitution, let us discuss physical changes and chemical changes. Physical change. Physical change is a change in the form of the matter, but not in its chemical identity. Example. Chemical change. In chemical change, one or more kinds of matter are transformed into a new kind of matter, or several new kinds of matter. For example, a substance is a kind of matter that cannot be separated into other kinds of matter by any physical process. Please remember, the scientific meaning element. Compound. Mixture. Mixtures are classified into 2 types: homogeneous and heterogeneous mixtures. Homogeneous mixtures. Homogeneous mixtures have the same composition throughout the sample. It has no visible boundaries of separation between the various constituents. For example, salt solution.
Chemical change is the product of the reaction. Take another example for understanding it more clearly. Take some water in a beaker, dissolve tablespoon of copper sulfate in it and add few drops of dilute sulfuric acid to it. It will form a blue colored solution. It is copper sulfate solution. Now take a polished iron nail and put it inside the beaker. Gradually, the blue color of the solution changes to green. It is because iron is more reactive than copper. It removes the copper from copper sulfate and sets at its place. We can say iron displaces copper from copper sulfate. By doing so, copper which is in compound form becomes free, while free iron gets attached to sulfate and forms a compound. Clearly, there is change in chemical composition. Where there is change in chemical composition, there is chemical reaction. How can we identify if the change is chemical or physical? We can identify a chemical change with some observations. Here are those. During a chemical reaction, one or more new substances or products are formed.
Free and bound electrons. We have already read that acquiring of a positive charge by a glass rod on rubbing is due to the transfer of free electrons from the glass to the silk. Silk conductors and insulators. These substances in which the charges can move with ease, that is, which do not offer resistance or hindrance to the flow of current, are called conductors. Material which do not allow the charges to move freely are called insulators. Wrong. Wrong. Dispersion of light. When a beam of white light is made to fall upon one face of a prism and is seen from the other face of the prism, the beam splits up into a series of colored bands. The colored bands are in the order red, orange, yellow, green, blue, indigo, and violet. The deviation suffered by red is least, and maximum deviation. What is the cause of dispersion? Earlier, it was assumed that the prism had some property of coloring light. To be sure about the real cause of the production of a spectrum, Newton performed a series of experiments. Experiment 1. Newton produced the spectrum of white light and isolated a particular colored ray, yellow, by drilling a hole in the screen. Experiment 2. If a second prism, exactly of the same angle and material, is placed with its
Introduction. In a homogeneous medium, light rays travel along a straight line. But whenever a ray of light passes from one transparent medium to another, it gets deviated from its original path while crossing the interface. The phenomenon of refraction takes place. Refractive index. According to this principle, if the path of a light ray, after going through a number of reflections and refractions, is reversed, then it always retraces its path in opposite direction. Suppose a slab of transparent medium having refractive index n is bounded by Consider the situations shown in Fig. Suppose medium 2 is air, a rarer medium, and an observer looks at the image from this medium, Figure. Twinkling of stars. When the rays of light from the star enters Earth's atmosphere, they meet a medium of increasing density because layers of air near the Earth are denser than higher. If light rays passing through an optically denser medium strike the interface with an optically rarer medium, totally reflecting prism. A totally reflecting prism can also deviate the path of a light ray through 180 degrees. Figure 11 shows a deviation in the path of a light ray through 180 degrees due to two internal reflections, one at the point D and other at the point F. In this mirage. Mirage is an optical illusion which is observed usually in deserts on hot summer days. To the animals or persons it appears that the distant object such as a tree is inverted. This creates a confusion that a distant road or Mirage. Mirage is an optical illusion which is observed usually in deserts on hot summer days. To the end, the brilliance of the diamonds and other precious stones. The refractive index of diamond is 2.47 and hence its optical fibers. Optical fibers are used to conduct light from one place to the other along curved path in a more effective fashion. The optical fiber consists of several thousands of strands of a very fine quality glass or quartz of refractive index of spherical refracting surfaces. Biconcave spherical refracting surfaces. Sign convention and assumptions for refraction at spherical surfaces. I. To derive relations between distance of object, u, distance refraction at a concave spherical surface, when lateral magnification produced by a spherical surface. Let A be an extended object placed perpendicular to the principal axis of a spherical refracting surface on left side. Consider a light ray starting from B and moving along BC. First principal focus. The rays starting from a fixed point on the principal axis of a sphere. Second principal focus. The light rays incident parallel to the principal axis of a spherical optical center. If a ray of light is incident on a lens such that after refraction through the lens the emergent ray is parallel to the incident ray,
Communication is the process of exchanging information or transmitting information. There are many types of communication forms, including speech, interpersonal, and organizational communication. Example: Guidelines. How to make notes. Step 1. Read the passage from the beginning to the end. Try to grasp the gist of the passage. Ask yourself, what is the passage all about? This will give you the theme and subject. Don'ts. Don't start before you have finished reading and understanding the text. Summary procedures. Understand the text. Underline the sentences which are important for the summary. Divide the text into paragraphs. Guidelines. In reports that are 1 or 2 pages long, readers should have no trouble finding their way around. Reports can be set out in 8 parts, but you won't always need them all. Guidelines. Format, layout. Layout should include date, receiver's designation and address, salutation like Sir. Content. It includes creativity in presenting ideas which are relevant to the topic of the letter. The content should be well organized for clarity and effective communication.